Okay, once again, interruptions everywhere. Energy level, which is just shells or periods. You should, all three of these words, or actually 4 words, should be synonymous to you. Energy level, period, shell, they all mean the same thing. They all mean we're looking at these numbers down the side. 1 shell, 1 energy level, period 1. 2 shells, anyway. So D is in 5. 1, 2, 3, 4, 5. D. What is the oxidation number of F? Not fluorine, but the letter F that they have here. Well, if it has 6 valence electrons, it's definitely going to be -2 because it's going to try and pick up some electrons. Is B a cation or an anion? All you have to do is look and see that it's a metal, and you know that all metals are cations, so cation. Cats are positive. I'm going to draw a little paw. I'm going to waste Haley's time just a little bit more. You want me to tell you the story about my dog? Never mind. Okay. What is the name of the compound formed between the letters B and F? All right. So here we have to figure out what B is. B is calcium. Calcium, 1, 2, 3, 1, 2, 3. So calcium. And F is right here, so it's 1, 2, 3, so it's sulfide. So it is calcium sulfide. Calcium sulfide, which is an ionic. Oh, here I go, off the camera. People are going to be yelling at me. Ionic compound. All right. Yes. All right. Organize the following elements in order of smallest to largest. Okay, so Ba is here, and Mg is up here, and Ca is right here. So from smallest to largest would be Mg, Ca, Ba. Mg, Ca, Ba. Ba. Because the largest thing would be on bottom. That would be Ba. The next smallest thing would be Ca, and then Mg. Because the trend is down and to the left. See that trend right there? Everything, this is bigger than this. All right, we're coming into the home stretch. Page 4. Okay, whenever you see a chart like this, I want you to promptly scratch through all the data about atomic radii and picometers. Because does that matter? No, it doesn't tell us anything. We've already discussed that things in the periodic table, when we get down the bottom here, the sizes go wonky. So some of the things over here are bigger than some of the things over here. They're the exception and not the rule. But knowing that, we can't judge off of the size. The size doesn't tell us anything. So I don't care that it's 118 picometers. What I care about is that it reacts slowly with cold water, because that's going to tell me, if I can find another thing that reacts the same, that's going to tell me what column it's in, what group it is, what family it belongs to, because all these are unreactive because they're in the same family. All these things react violently in water because they're in the same family. So it reacts slowly with cold water. Okay, no observable, reacts slowly. So we have a candidate there. No observable, no observable, no observable, no observable, reacts very slowly. We have a possible candidate there and reacts vigorously. So these are our 2 candidates, but we have a little more piece of information here. Gas at room temperature. Gases at room temperature are nitrogen and oxygen and fluorine and chlorine and bromine, right? No, sorry. We're going to stop at chlorine, right? So we know all of these are gases and all the noble gases are gases. So I'm going to guess that it's probably in the same family as chlorine and not as the same family as magnesium, which is all metals and is no gases. So if they ask me what family of elements would I expect this new element to be in, I would say it's in halogens. Because chlorine is in halogens. And this is going to be in the same family as chlorine. Why? Because chlorine is a halogen. And the new, in quotes, element reacts like a halogen and is a gas. And I could add all that stuff, but I'm going to quit writing. Otherwise, Haley's going to come in here and beat me to death with my pointer. Okay. Is the element a metal, non-metal, or metalloid? Well, halogens are nonmetals. Is the element a cation or an anion? Well, halogens are all anions, -1. I already told you how I know. I know because it reacts slowly and because you said it's a gas at room temperature. With those two pieces of data, that's how I know. Give the charge formed by the ion. Charge formed by halogens is -1. Explain how you determine the charge. Well, I said it was in the halogen family, and everything in the halogen family has the same charge, a -1. I'm not going to write that out. I feel like that might be a waste of your time. But if it's in the halogen family, if it reacts like a halogen and it's a gas, and if it quacks like a duck and the Pope wears a funny hat, then it's definitely a -1 charge, right? Okay. Does the element have a smaller atomic radius, smaller or larger than potassium? Well, let's figure out where potassium is. Potassium's way over here, and this element's going to be over here. Let's see. Potassium. So they said our new element has 118 picometers and 111 silicon, so that's going to be way up here. So I'm going to say it's smaller than potassium. Smaller. One, it's way over here to the right. And 118, this is the only place that size would have come in handy is for this question. 118 means that it's going to be in this row with silicon. It's going to be somewhere near chlorine. When bonded with sodium, does it form an ionic or a covalent bond? Sodium is a metal. And if sodium is a metal, and my new thing is a nonmetal, is a halogen, this is going to be an ionic bond. What is the electron config of bromine? Oh, good Lord. Okay, so we have 35 electrons. 35 electrons. So let's get started. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, do we need, let's see, 2, 4, 10, 11, 12, 18, 19, 20, 20, we need 15 more, so we're going to go to 3d10, now we need 5 more, and after 3d we do 4p5, 2, 4, 6 is 10, 11, 12, 18, 19, 20, 30, 35. 4p5. Now the way to check this is if it has 35 electrons and it's bromine, we need to go to period 4 into the p block. 5 steps. 1, 2, 3, 4, 5. Bromine, oh look at that. So this is the correct electron configuration for bromine. And that concludes today's videos. I hope you at least got something educational out of them. Good luck tomorrow on the test. The test is very similar to this review, so you should be able to do it, right? Right. See you tomorrow, guys.